called 6-2 substitution. Okay, so yesterday we talked about how to graph and figure out where they cross based on the picture. Today we're going to solve a systems of equations using algebraically. Okay, but most importantly is we're going to get exact answers here. Okay, the graphs are great to get you about what the answer should be, but we don't actually know sometimes, especially if it's crossing at a halfway point. We don't know if it's actually like 0.5, 0.4, 0.6, so we're just estimating. So graphs are awesome to get you about what the answer should look like, okay? To get exact answers, you need to use some algebra, all right? So we're going to talk today about substitution, which is one of two ways to do it mathematically instead of looking at the picture, okay? So you have the picture, which is graphing. We're going to look at substitution today, and then the next time I see you, we're going to look at what's called elimination. Okay? So there are three ways to get answers to these problems, but graphs are not the best. Okay? Because if it is like 1.2, how do we tell if it's 0.2 or 0.3? We can't on the picture. Okay? Alright, so looking at this, so what we're going to do is we're going to review what we did yesterday with the graph, and then we're going to transfer that over to what does it look like with substitution and see how close our graph is. Okay? Alright, so on the first one here, x equals 2y. What am I going to have to do here first before I can graph this?
Divide.
Ashley, start us off.
Divide by 2.
Good. So you're going to divide by 2, right? We got to get the y by itself. All right? So y equals, all right? And on this one, please, please, please do not put 2x. Right, Ashley? No 2x. Okay? 1 over 2. Right? It's 1/2 x. So now, where do we start at on this picture, Sam?
You start at 0, 0.
Okay, good. So keep in mind there is a plus 0 if you need to put that out there. Go ahead and do that. But you start at 0, and then a slope of 1/2. What would you do there, Sam?
Up 1 over 2.
All right, so up 1 over 2. Okay, now so get some points across that grid, or use a ruler, whatever you want to do there. Alright, now we're going to go to the second equation. Ben, what do we need to do here on the second equation?
4x to the other side.
Okay, I like that. So subtract the 4x over. So that cancels. So we have 2y equals negative 4x plus 15. Okay, then what would you do?
And then we divide 2, or you divide everything by 2.
Good, divide everything by 2, so that cancels. So y equals, okay, what's negative 4 divided by 2? Negative 2. All right, what's 15 divided by 2?
7.5.
Very good, plus 7.5. Okay. All right, so now if we're looking at this, where are we going to start our graph at?
7.5.
Okay, so we're going to start at 7.5. So if I kind of count that up there, 7.5 is going to be right on top of that arrow right there. 7.5. It's a halfway point. Okay, so now the slope is negative 2. So how are we going to do a slope of negative 2? Bria, what do you think?
You go down 2.
And then what?
Over 1.
Good. All right, so go down 2. And when you guys go down 2, you're going to be at the halfway point, okay? So go down 1, 2, halfway point, and then over 1. Okay, so you'll kind of be at the halfway mark on all these. Down 2, over 1. Okay, and then draw your line. Hey, wait. Oh, just to you?
Can you read my writing?
Yeah, okay. Okay, so where do these cross at? About where do you think? You just have to kind of estimate this. Ben, what do you think?
3 on the x and 1.5.
Okay, so he's saying 3 and 1.5. Do we know for sure that that's 1.5? Could it be like 1.4?
Yeah.
Yeah, it's just hard to tell, right? So this is what I'm talking about. A graph is good to get about what the answer should be, okay? But it doesn't work real well when we get decimals and fractions involved, okay? All right, so what I'm going to do now is I'm going to draw a line right here, and now I'm going to show you a substitution what this is going to look like. So I'm just going to rewrite it. X equals 2y. So I'm just rewriting my two equations real quick. And 4x plus 2y equals 15. Okay. All right. So now, when I say substitution, what do you think of?
You plug numbers for
Substituting
X.
in for variables.
Substituting in for variables.
Well, I was thinking you take the 2y and put it where the X is at.
That's right. Nice job. Okay. So if you think about substitution just like in everyday life, like a substitute teacher, right? A teacher would come and replace me, right? If you have a substitute on the field or the court, somebody is replacing you. You are out, but someone has come in place of you, okay? It's the same thing here. You're going to substitute. You need an X or a Y equals. Stop being obsessed with Y equals. I know we've been obsessed with it for a while because we've been graphing and doing equations for an entire chapter now. So we're going to have to get out of the mode of always having a Y equals. Okay? It's okay to have an X equals, like on this problem. X equals is a good thing. Okay? So this tells you where it's going to get plugged into, and this is what is going to get plugged in. So I'm going to plug in for X, and what am I going to put in place of X? 2y. Okay? Now, when I'm talking about that, that means we're going to take this guy and plug him down here into the other equation. So when we substitute, we're replacing it in a different equation, not the same one. Okay? So when I'm looking at this, okay, I'm going to take the 2y, and since it said x equals, I'm putting it in place of the x. All right? So now I've got 4, and out goes the x, and in comes the 2y. Okay, so I replaced him. I substituted him. Player X is out. Player 2Y's just come in the game. Okay? And then plus, and then you've got 2Y equals 15. Just rewrite the rest of the equation. Okay? So again, replace. Take that guy and put him in there, and the X is gone. If you have an X and a Y at this point, you know you're wrong. Okay? You either have to have X's or you have to have Y's. You can't have both. Okay? So now it's just solving equations. How are we going to solve this? What are some things we need to do? Bria?
Addition.
Okay, so what will that look like?
8y plus 2y equals 15.
Okay, good. All right, Tessa, what would be the next thing here I would do?
Add the 2y's together.
Okay, so 10y equals 15. And then what are we going to do? Go ahead, Tessa.
Divide by 10.
Good, divide by 10. So you may know what's 15 divided by 10. Don't let me down, guys. Huh? No. What's 15 divided by 10? 1.5, that's right. 1.5, 1.5. So now if I kind of look back over here to my grid, we're saying y is 1.5. Well, we did a pretty dang good job, didn't we? All right. Now, the problem is, though, we have an x. We don't have any x over here. Anybody got an idea on how we can find what x should be? Ashley?
Do you put it, do you take the x from the first equation? And then, or should you take the x from the top or bottom equation?
I think you take the bottom, put it in the top.
You put in the y equals 1.5 into the equation with the x.
Very good. Okay. You guys are going to use whatever you get here. So whatever you get there, and you're going to plug it back into one of the two equations. Your pick. Whatever one looks easiest to you. So if I'm looking at these two equations, which one do you think I'm going with?
The first one.
Yeah, the first one looks way easier. So that's where I'm going. So if you're going to substitute your y back in, so x equals 2 times 1.5. All right, so what is 2 times 1.5? 3. So my coordinate point, and you have to write a coordinate point, will be 3 and 1.5. And that's my answer. Okay, does anybody have a question on that? Okay.